Hello class, this is CSE-5250, sections 1 and 60, week 13, fall 2023. So Thanksgiving's right around the corner, and I figured it would be a good time to give you the instructions on your final project. So much like with the midterm, you are to write the sieve of Eratosthenes using MPI. Now, I would have liked to write it in such a way that it uses some of the functions that we were looking at, say MPI reduce, MPI all reduce, MPI broadcast. But I've not been able to do that, so instead I am giving you an implementation of the sieve that I wrote up for a past version of the class. So on Canvas, you will be linked to videos from, well, an earlier version of the class, but it has a walkthrough of what to do. There are lots of checkpoints as well, so that's why, if you look here, all these files are basically just different steps of the sieve, but if you look at the videos that I have linked on Canvas, it gives you instructions on what to do. Now, because of how the sieve is set up in those instructions, you cannot run the sieve using just one process. Rather, you will be benchmarking it with starting with 2 processes, and then 4 processes, and then 8. And then you are encouraged, if you can, to go with as far as your computer can handle it. So 16, 32, 64. Maybe at that point, maybe past 16 or maybe 32, depending on what kind of computer you have, that's where you would stop. Because you might get diminishing returns after that point, simply because your computer might not be able to run that many processes at once. However, as before, you are encouraged to expand the table. Say, maybe you don't want to stop at 1 million as a search maximum. Maybe you want to go up to 1 billion. And if you can, I would encourage you to do that as well. So, questions are similar as with the midterm, where is the sweet spot for thread count, though in this case it's process count, not so much thread count anymore, because we're working with processes, not threads. Where is the sweet spot for workload size? So those 2 questions are now 20 points combined, because you'll be answering an extra set of questions comparing your experience with OpenMP and MPI. Which did you feel like was easier to program, for example? And which one do you think would benefit from special hardware? So that is the sieve of Eratosthenes using MPI. So the videos for the sieve are already available, and I will link to them. I will provide links to those videos on Canvas. So by the time you watch this, videos, you should be already good to go with the sieve. When is this due? I have it set to be due on December 13th, but the submission field for that is available up to the night of the 16th. Don't submit it any later than that unless you had a good reason as to why you would have to submit it late. Say, unexpected circumstances that required you to submit it later than the 16th. It's just that I need the time to grade everything, because grades are due, I believe, on the 21st of December. So get everything done by the 13th, if not the 16th. That way I can have everything graded in due time, and you should get your final grades for the course after that. One other thing. I have right now the sieve that basically me from the past had described. And there are a few things that this sieve has that the OpenMP sieve does not have. One, if I comment out this code, what this code does is it prints out the execution time in a file. Also, one thing we can also do is this. It turns out we don't need to use standard chrono for this, because MPI also has its own equivalent of calling, I should say, MPI has its own means of getting the time for the start time and the stop time. So we could basically replace high resolution clock :now with MPI underscore W time. I would copy that and copy that same thing here, and exact time, that's the execution time. We can simplify this even further and just say exact time equals stop minus start. And we don't even have to say exact underscore time dot count anymore. We just have to say exact underscore time. So that's one thing we can do that MPI gives us with regards to getting the execution time. But it's equivalent to using standard chrono to get your execution times. I just bring this up because if you look through the textbook, it says, hey, there's this function you can use to get execution times. You just gotta call it before and after you do the algorithm you want the time. Subtract one value from the other, and you'll get your execution time in. And I should mention this right now. If you use MPI W time instead of standard chrono, the units are in seconds, but they are floating point values. In fact, this function here returns a double. I just opted to use auto because, well, that was already there. I'm saying this right now because you basically have options on what to do to get the execution time. One other thing, and this is specifically for CSE 5250 section 60, and anyone who may have missed the in-person section for section 1. We currently have the student opinion of teaching effectiveness surveys being administered at the moment, so if you are able to, I would like you to take the time to fill out the survey. It is basically for you to answer honestly and truthfully what you think about the class, how well have I been teaching. And your answers are anonymous, and this information is used by me. No, this information is used by the department and myself to better improve the class. So, if you haven't done so already, take the time to fill out the surveys and basically answer the questions truthfully and honestly. It used to be these surveys were done in class. We would take time out of the class to have me appoint a student to pass out the surveys, have everyone fill them out, and then they would take those surveys to a main office somewhere. But now, and particularly because we've had online classes for the past few years, now this whole system of administering SOTIs is done electronically. So you just gotta log in, fill out your surveys, and we're good to go. Just, if you haven't taken the time to do that yet, do so as soon as you can. Alright. That's about it for this video. Have a good Thanksgiving. Stay safe. stay warm, and watch out for traffic, because particularly with high winds, for example, those can and have tipped over large semi-trucks. So be careful out there when you're driving. Stay safe, stay warm. Get yourself into a food coma, I guess, and we'll meet back next week to talk about the last things in class, which is I would like to talk about NVIDIA CUDA. And if I do give out assignments for that, they will be extra credit. And they will be extra credit points that will go towards your homework assignments. One other thing, I have graded nearly everything, but there's still a few assignments left to grade. So if you see any discrepancies regarding the grades, or if there's something that has been, or if you see something that hasn't been graded yet, let me know. But I will be taking the time to grade anything that hasn't been graded yet over the Thanksgiving break. So if you see any discrepancies with the grade, let me know via email or Canvas message, and we will pick up from there next week, week 14. Alright, thank you, class.